Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, Gibran here, and in this occasion, I would like to discuss about CPUs on the topic how do Central Processing Unit, aka CPU, works. Firstly, in our daily life, it is undeniable that we use almost every kind of electronic devices, such as mobile phones, laptops, and computers. All of them are consist of smaller components which have different tasks. Even if it's different, there's a fundamental flow where almost all of those components follow these fundamental rules. But the thing is, not many people in the world know how about CPUs work. So here, I want to uh, simplify the process uh, in the CPU that where the data is input, processed, and then output. So let's start. This is the general flow image of simplified version of the CPU. It consists of input, control unit, registers, combinatorial logic, main memory, and output. Well, it maybe seems overwhelmed, but let's break this down one by one. So firstly, as we know, the data is inputted from the user interface, such as keyboard, mouse, or pointers. And here, think of input like as two pipes. One is for data, and another one is for instruction. Both of them will be inputted on the same section, but in the input itself, it will be divided into two parts. The control unit will handle the instruction from the first pipe to inform the other departments. In the other hands, this will be stated as a control station, a um, main control station to CPU who know each other to make other parts know what to do. So after the instruction is sent to the control unit, how's the data? The data be waiting, will be waiting in say a waiting room between the input and in this component there is some kind of waiting room here, and while they're waiting to the instruction to be delivered to all departments, they will be waiting here. After waiting, and all departments know what to do, this is the real room where data is processed. It can be summing up, performing arithmetic operations, logic gates, and multiplication, etc. And easily, almost all of it is consists of simple logic, simple performance, simple arithmetic performance. At of the most of the time, the perform itself it's not enough, will not suffice. But we need some storage rooms. It is small to handle the temporary data from combinatorial logic to then will be reprocessed again. So think of registers as an additional small storage room. This is because this register is relatively small. But there is a bigger one, a main memory named. This is for some complicated process that won't be enough if we just use registers. So a bigger part of registers, a more uh, high usage data will be stored here for some time before it will be processed again or divided into pieces take it from to the register again, and then to the output. So after all, the data is already finished and processed from all of these departments. When the data is ready to be served and it's to be output, uh, the data will be sent to the output, either to the user, to the display, to the sound interfaces, or even, in most cases, it will be repeated again to process even further. So many process do this uncountable many amount of times. So there is some technical words that um, that will be in the CPO itself, or just for no terms such as opcode. Well, I said before that there are some instructions that will be executed in the CPU, and the name its own name, and the name is opcode. So there's another one is IO. IO is abbreviation for input and output, just for simplify. Then memory. Memory is not just as we think memory is a brain, but it is small parts, actually a real part, where computer stores data either temporarily or for permanently until we or someone delete it. And logic gate, as I said before, is an electrical term for deciding how the data will be outputted. For example, we have to on-off switches, and we would like to know how is the output if we turn on those things or if we turn off those things. And well, Ryzen, as I Ryzen in text, is one of the famous processors in substrate of AMD Corporation, like Intel processors. And thank you for understanding my